Okay, hi guys. So today I'm going to do this AtCoder regular contest 137, and I thought that this was an AtCoder beginner contest. That's why I said that I would do this. But yeah, so ARC aren't that easy, and especially not that easy to do on video. But yeah, I'm a little busy also. I don't have 2 hours for this, so I'll do the first 50 minutes, and however much I can do in that time, that I'll post. And apart from that, go to the comment section, see the pinned comment. There is the link for the grand contest by Newton School. So I would highly recommend you to register for that because there are like a lot of prizes and the contest is also very good. So this would be very good for your exposure and experience. So go register for that. The prizes that are there are not for just for the top performance. They are also for a lot of random prizes are also there. So even if you solve just a single problem, then also there's a good chance that you might win some prize. So go check that out, and let's start with the contest. And there's a good thing that I have registered as an unrated participant. So I've seen this post. It is something like we can choose our participation to be unrated, and then what will happen is that we our rating won't be affected, and that's really great for me because um, I'm not participating with full dedication. I'm just explaining the solutions while I'm participating, so I'm wasting a lot of time. So because of that, it's really great that my rating won't be affected by this. So yeah, let's start. The first one is coprime pair. Okay. So in this, we are given two integers L and R, and we want we want pair of integers that satisfy both the conditions that yeah, okay, that they are within the range and the GCD is 1. Okay. So we want the maximum possible value of y minus x such that uh, such that this thing happens. So it can be proved that at least one such pair exists. And yeah, that is obvious because if you take two consecutive numbers, their GCD is always 1. And that means this value will at least be 1, but we want the maximum value that this can take. So basically, we want two coprime integers such that the gap between them is the maximum. Okay, right. So how do we do this? For example, if we have 14 and 21, 14 and 21, so there are like a lot of numbers in between. And what we want to do is we want the gap between two coprime integers to be maximum, right? So this means we want like x comma x plus something, and we want the maximum a such that the GCD between these two is the maximum. So the GCD between these two is actually equal to GCD of x and a. This is just due to that Euler formula, Euclidean algorithm basically. So we can subtract x from here. Yeah. So we want the maximum difference, we want the GCD between x and a to be the equal to 1. Okay. So basically, whatever our answer is, we want the GCD of that and a point that we choose to be 1. So if any number we pick, let's say if we pick 14 or if we pick 15 and so on, so we will get a maximum value that we can have as a. For example, if we pick 14 as x, then the a can be up to 7 because if we have more than 7, we will go beyond this. If we pick 15, the a can be up to 6. If we pick 16, the a can be up to 5 and so on. Yeah. So then I guess what we want is we want the maximum number that is smaller than this and is co-prime with this number. So if we find the maximum number that is smaller than 7 and co-prime with 14, so that turns out to be 5 and 5 is the answer. Here it turns out to be 4, but 4 is not the answer. Here it turns out to be 5 and 5 is the answer. So yeah, something like that. for each number we have like the maximum value of a, and we want to pick a number smaller equal to that such that it is co-prime with the x that we pick. Okay. Or maybe we can think of it in some other direction. Like if we choose the a first, then it's about picking something that is co-prime to that in that range. Mm, if we pick 7, we cannot do it. Wait a second. Didn't expect. Yeah, just a second. Okay, so if we pick 7, we find there must be something like this won't be too, this won't get too small, and we should be able to do it. Mm, so if we start with the largest A and that doesn't work, we start with the second largest A. Like we try to check if it works with 7, then 6, then 5, 4, 3, 2, 1. Like this, if we keep trying to do, then maybe we will find the answer very soon, like in a very less number of steps, maybe. Because like I guess very soon we will just find a prime number itself. But these are very big, right? L and R are very big, but wait a second. But these numbers are consecutive, so so it's like when we pick 5, we want 5 to be co-prime with at least one of these numbers, right? Maybe that's not a big deal. Because, but no, but 5 is very small, right? So it works here, but might not work everywhere. Something like what I think is maybe if we keep decreasing like this, whatever these values are 7, 6, 5, 4, 3, 2, 1, I think very soon we will just find a prime number. And prime numbers are very likely to be co-prime to something. Like if we have 3, 4 numbers at least, a prime number will be co-prime to at least one of them, I guess. Because the only common factor can be the prime number itself. And if it's there in one of the numbers, then it won't be in the immediate next number or something. So maybe we can just manually iterate and get the answer. Let me Google this thing. Okay, so this is the normally what's the gap between two prime numbers, right? And yeah, okay, it can be pretty big actually. No, can't be very big, right? Yeah, prime gaps are actually very small. Yeah, prime gaps are small. So that means if we keep if we just keep manually decreasing this value a, we'll very soon find a prime number within I guess 1,000 numbers. And then if we find a prime number, it's probably going to be co-prime with at least one of the numbers that we have. So I guess we can just do a quadratic type of algorithm here, and it will work because 1000 is not that big. So let's try that. I'm not sure if this is the intended solution, but I really think this will work. Okay. So the maximum value of a that we picked there cannot be more than r minus l, I guess. Right? Yeah. And now what I want to do is I want this value to be a second. I goes from L till R like this. After each step, my A gets decreased by 1, right? So basically, I'm iterating like this 14, 15, 16, and so on. And this value A is decreasing like 7, 6, 5, 4, 3, and so on. Okay. Now what I want to do is I want to check if this A is co-prime with at least one of the numbers that we have encountered. So let's iterate on those numbers from L till I. Okay. And if at least one of them is co-prime, so if the GCD of A comma the number is equals 1, that means our answer can be A. That's it. Okay, now this 2, 4 gives us 1. That's fine. I mean, definitely these answers are correct. We were worried about the TLE, and I don't think there would be a TLE because prime gaps are very small. Yeah, this is just a naive solution, but this works because prime gaps are small. I guess this works because the prime gaps are small. Okay, yeah, so this works in a very less amount of time, and it works because prime numbers are very close to each other. Let's say the maximum gap between two prime numbers, two consecutive prime numbers, is not more than maybe 1000 or something, 1000 or 2000 at most. So because of that, we find something like this very, very quickly. So yeah, that's it. Okay, let's see the next problem. Okay, you are given an integer sequence of length n consisting of 0 and 1. Okay, so you will do the below operation exactly once. Choose the contiguous subsequence of a, flip the elements in it. Okay, okay, okay. Oh, okay, contiguous subsequence, right? So that means a subarray, and flip the elements in it. So what are all the different values that your score can take, right? This one, I guess, should be easier than the first one, at least the way I solved it. Okay, so I guess it's like we have a sequence of 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, something like this. And we can pick any subarray like this and then flip all the zeros and ones. So yeah. So basically when we flip this and if we keep a count of all the zeros and ones that are present there, so we have like 4 ones and 1 0. And when we flip this, it will become like 0 1 0 0 0. So this is actually like a -3, I guess. This is equivalent to a -3. So you can see that earlier we had 4 ones and now we have just a single one. So this is equivalent to a -3. Because choosing this array would change the score by 3. It will decrease the score by 3. So basically every sub-array will have like a particular score. So this is a +2 because when we flip it, we will have 2, actually +1. This is a +1 because when we flip this, it becomes 110. And instead of 1, we have 2 ones now. So this is like a +1. If we pick something like this is just 0 and so on. So I guess for every sub-array, we need to know the difference between the ones and 0. Yeah, that's what it is. So like in this range, we have 3 ones and 1 0. So the difference is 2. In this range, we have the difference 0. In this range, we have the difference -1 or something like this, right? And so we want all the unique differences, and that is our answer. Okay. All the unique differences between the number of zeros and ones um, in our ranges. So maybe like I think it seems natural to try to do like a prefix some kind of thing of this. So let's say we are counting, we're storing the value of count 1 minus count 0, and we're doing like a prefix sum of this. So here we get -1, and then here we get 0, then again -1, 0, -1, 0, 1, 2, 1, 0, -1, 0, -1, 0, something like this. Okay. And then for each value that we pick, and here we have a 0 because prefix sum starts with like an extra element. Okay. So at each element, we can basically just see how many of the previous ones, how many previous distinct values can we subtract and get like. So we want basically the total number of distinct values that we can get by subtracting 2 of these values. So like 2 minus 1 gives us 1, 1 minus 0 also gives us 1, so that's not unique. Then 2 minus 1 gives us 3, and so on. So we want the total number of unique values that we can get in this way. Okay. Total number of unique values that we can get like this. And one observation might be that wait a second. What's the biggest value? 2 minus 1 is 3. 3 is the biggest value that we can get. And what's the smallest value? I guess this -1 -2 is -3. So I think maybe we can get every value in between them. Let's try to verify this here. 2 minus 0 is 2. 2 minus 1 is 1. Then 2 minus 2 is 0, obviously. -1 minus 2 is -3. -1 minus 1 is -2. And then -1 minus 0 is -1. Yeah, exactly. So we just need to find the minimum and the maximum value that we can get in this range. Yeah, so we just need to know the minimum and maximum value we can get, and everything in between can definitely be formed. I guess so, because like at each step, basically, our this cumulative value, it's getting increased or decreased by just 1. So if we have like x here and if we have y here, so definitely in between x and y, we must have all the values between x and y, because we will go something like this, right? So like, let's say if x is smaller and y is bigger. So we will definitely have x plus 1 somewhere, we will have x plus 2 somewhere, because we can only do like plus 1 or -1. We cannot do +2. So we cannot skip any value. That means every value that lies in between x and y is definitely in between here. Yeah. Okay. So I guess that's that. Okay, so we will take n, we will input n, we will take an array of length n, we will input that array. Okay, we will form a prefix sum. Okay. Then we will do something like this. Mhm. So if this AI is 0, then we do -1, otherwise +1. Okay. So this prefix sum that we get, now we want just the minimum and maximum value in this. Okay, initially both are 0. Okay. Okay. Mm, PFI minus MN. So current minus minimum. That's what the maximum might be, and current minus maximum. That's what the minimum might be. Yeah. Okay. Then our answer is just answer max minus answer min plus 1, I guess, because if both are 0, then answer is 1. Yeah. 1 and 0, then answer is 2. Okay. Cool. So yeah, that's that. And I would like to explain what these Amax and Amin functions are. I have defined these, and basically this is like the plus equal to version of max. So what this will do is this will store the maximum of max and PFI into this variable max, like this. So yeah, this I hope will work. 4, okay. 6, I hope. Cool. And 3, 3, okay. Working so far. There are a lot of coolers working. I hope my noise cancellation of this mic is working properly and you people are not able to hear that. Okay, so we got 2 at least. So this video is not a total waste. Third problem is usually difficult in ARCs. So maybe this will take like 20 more minutes and that will be the end of the contest for me. But let's see. Okay, so we have a non-negative sequence of length n and all the elements are pairwise distinct. We will play a game on this. Alternatively, take turn. Alice goes first. Okay, the normal drama. Choose the largest element at the moment. Replace it with a smaller non-negative integer. Okay, so choose the largest and decrease it by something. And it must still be pairwise distinct. Okay. Oh, oh. Right. So one will lose when the values become like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till n, 1 till n. If all the values are there, then you cannot decrease it to a non-negative integer. Okay. 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 So this definitely does not seem straightforward at all. Definitely complicated. So the question is kind of like we have a lot of numbers. Actually, it's given in increasing order, but I don't think it matters. It's given in increasing order, but I don't think it matters because after some moves, it won't stay in increasing order. Okay. So you can pick like a big number and decrease it by some value, and you want to make sure that the numbers still stay pairwise distinct. Something like take this and decrease it to, you can't decrease it to this, but you can decrease it to this. And then on the remaining thing, we play the game again. Right. So this does not seem straightforward. It's definitely almost certainly intuition based, and I can foresee how the game will end. The game will end with all the numbers 1, 2, 3, dot 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 n in some shuffled order, not necessarily this increasing order, but in some shuffled order we will have all the numbers, and that's what the last move will be. And one more thing is that every time we pick the biggest number only, we cannot pick any arbitrary number. Okay. Okay, so I guess it definitely depends on the numbers that we have. Yeah, so in this one, Alice can definitely win because she can just pick the 4 and decrease it to 1 and just win in the first turn. Wait a second, 0. Oh, non-negative, right. Yeah, actually, the numbers will be like, wait a second. So the numbers will be actually from 0 till n minus 1. That's the same thing. It's fine. Okay. So in this, maybe Alice will decrease it to a 3, and then Bob has to definitely make a 0 and or 1, and then Alice will make the other thing. Here, Alice cannot make the first move, so obviously Bob will win. Okay. So it's about like the moment you make a 0, that is fixed. You cannot change it again, and then you have to play the game with the rest of the elements. Then when you make a 1, that is also fixed, and you have to play the game with the rest of the elements. And then when you make a 2, that is fixed, and you play with the rest of the elements. How does that help? So here's what I'm thinking. I think the game is like very, very favorable for Alice. And it's like, let's say the largest number that is there. Yeah. So let's say I'm just assuming a case that the largest number is quite large. Okay. Whatever the largest number is, let's say it's quite large. So we can do a lot of things. We can decrease it till here. We can decrease it till here, till here, till here, and so on. Not till here, I guess. This one is not allowed. But yeah, a lot of options are there. Okay. And what I'm trying to say is, let's say one of them is the winning state, like one of these, or let's say, like let's just leave this one for now. Let's leave this one, and apart from these, consider all the rest of these, and say that at least one of these is like a winning state. Okay. So let's say at least one of these is a winning state. So what will happen? So if at least one of these is a winning state, then Alice can definitely decrease uh, her value or this largest value to one of these. And then, wait a second, if any of these is a losing state, yeah, if any of these is a losing state, then Alice can force Bob to a losing state, right? So, for example, let's say if this is a losing state, then Alice will, in the first move, decrease the value till here and force Bob in a losing state and win. If this is a losing state, Alice will force here. If this is a losing state, Alice will force here, and so on. But what if all of these are winning states? That means there are no losing states here. So then that's what I left this one for. Then what Alice can do is Alice can just take Bob till here. Okay. And then the next step will be playing like this. So now again, Bob has to move on one of these. And since all of these are winning, that means Bob will lose, right? So my observation is that if the last number is greater than, I guess, if the last number, or let's call it an, if an is greater than an minus 1 plus 1, then definitely Alice will win. Yeah. No, wait a second. Basically, what I'm trying to say is if Alice has at least two moves in the first move, then Alice will definitely win because, like, yeah, I think this is the condition. Yeah. It's like if Alice can perform a move on the last element without actually changing what the biggest element is, so she can either pick the losing state that is present anywhere below, or if there is no losing state, she can just decrease the thing by one and then force Bob into that losing state because all the other states are winning. So this is one condition, but this is not the only condition. But yeah, this is one condition for sure. So the game is actually kind of easy for Alice. But now let's consider, let me just see some examples actually. Yeah, in this one, Alice is the winning. Okay. Now let's consider the case where the last element is exactly equal to the second last plus one. But in between there might be gaps. But the last element is exactly equal to second last plus one. So only this case we care about. So in this, Alice has some options. She can go here, here, maybe here, here, something like this, or here. Yeah. So now Alice has multiple options, but whichever option she picks, this one will become the maximum now. Okay. So it might be possible that all of these moves are winning states. So all of these lead to a winning state. It might be possible. And one thing is for sure that this value must be changed to this minus 1. Because if we don't do that, yeah, so what I'm trying to say is, let's say if this is 20 and this is 19 and this is 10 or something. So this must be changed to 18 Because if we change it to anything smaller than that, like let's say if we change it to 17, in the next step we will have 19 is the biggest and 17 is the second biggest. So that will be a problem because then Bob will have like a, uh, gap of 2, and then Bob can either win in this single move or just go to 18 and force Alice to a losing state. So this 20 must definitely go till this 18 thing. But what if we had an 18 here? What if this was 18? Then what do we do? So do we go till 17 or do we go somewhere else? It's like if it's my move, I can always make sure that the other person does not win in a single move. Like basically, a single move win is something like the largest is x and the second largest is not x minus 1, x minus 2 or smaller. So in my move, it's like if I start with x plus 1, I can always take it down to x minus 1 if x minus 1 is already not already brilliant, right? So it's like it's obvious that I won't let the other person just take the victory and we'll all play normally, kind of. So it's all about who does the last move. Like when we actually reach 0, 1, 2, 3, and minus 1. So who reaches there? So maybe that's about odd even kind of thing. Like who is on the odd, who is on the even. It's like if 18 is not present, then this 20 definitely has to be 18. No other choice. But if 18 is already there, then there's some choice. And that's the case that we have to handle. It's like unless. Mhm. Hmm. And to win, like what other way is there to win? Like if we don't have that two gap thing. Yeah. If what if we had like a 0, 2, 3? Yeah. What if we had a 0, 2, 3? Then in the first move I will make this 1 and I win. But what if we had like 0, 3, 4? In the first move I make this 2. The second move that person will make this 1 and then I lose. What if we had 0, 3, 4, 5? Then I have options basically. I can go to this 1 or I can go to this 2. That's what you have to choose. So should this 5 become 2 or 1? If I make this a 2, then this person will make this a 1 and I lose. But if I make this a 1, this person will make this a 2, and again I lose. It's not like it will never matter. Plus, if it even if it doesn't matter, how will we find the winner? Okay. First step was kind of easy, that if this is 21 and this is 19, definitely Alice wins. But apart from that, doesn't seem that obvious. If we have like a 19 here, we know that we need 18. But if we already have 18, then we don't know what to do. But one thing we know for sure is that all numbers will definitely be visited like once. Yeah, okay. I think that's the point. Yeah. So my idea is that if like the largest number is 1000 and the second largest number is 999, okay? And I don't care what the other numbers are. I know for sure that at some point we will definitely have 998 in the array. Maybe it's already there, but yeah, we will definitely have 998. We will definitely have 997. We will definitely have 996. And we will have all the numbers up till 0. That is for sure. Maybe some of these are already there, but like at least once all of these numbers will be visited. And maybe this can help us count something like odd even kind of thing. Yeah, because all of these have to be made, and some are already there, so some others will be made, and then we can just count the number of moves, and based on that, odd even kind of thing we can do. Okay, so if we know that the last two numbers are 1000 and 999, we know for sure that definitely. mm, Wait, what am I saying? Yeah, okay, yeah, right, exactly. So I know that in the first move, 1000 is the maximum. I know that in the second move, 999 will be the maximum. In the third move, the 998 will be maximum. In the fourth move, 997 will be maximum, and so on. So this is for sure because we're always making sure that we get like a smaller number. So in the very last move of the game, n will be the maximum if all the players play optimally. And then when this gets converted to n minus 1, that's when the game gets over. And yeah, so we can just count the total number of moves that we have to take to do this. Okay, I guess I've gotten this now. This was good. Now n is at least 2, right? So if a n minus 1 is greater than a n minus 2 plus 1, then definitely Alice will win. Okay, because I explained that in the beginning. Yeah, so this was that. And then what about in the other case? So in the other case, I just have to count the number of moves. And I know that in each move, the maximums will be like in the first move, the maximum will be an minus 1. In the second move, the maximum will be an minus 2. In the third move, sorry, in the first move, 1000 is the maximum. In the second move, 999 is the maximum. In the third move, 998 is the maximum, and so on. So like that, it will happen. So I can count the number of moves like this. So in the first move, the maximum is a of n minus 1. And in the last move, the maximum is n. Okay. And I guess we have to add a 1 here, because if what if that itself is n? Yeah. So these are the number of moves that will occur in the game. I added 1 because like, what if the largest number is n? Then this gives 0, but we can do 1 move, right? So we know the number of moves, and based on that, if that is odd or even, we can decide whether Alice will win or Bob will win. So if this is even, then Bob wins, I guess. Okay, that this was obvious, and this is also obvious. Okay, let's see. Hmm. This was quite good actually.